My name is Barry McFarland. I'm doing the math review for college algebra, and I'm going to follow pretty much the review sheet that is available to all students. We have a student here who is participating, and she has requested that we go over the entire review for her sake, because she wants to know how to do the problems instead of having an open session. So I'm going to go through the entire review for college algebra from number 1 to number 36. These are available, by the way, guys, on D2L, I believe, a lot of times, right? And also through the math lab. So here we go, number 1, and these are typical questions. These are the type of questions, typical difficulty level, typical type of question you're going to run into on the final. Obviously, they're not identical, but the whole idea with math, guys, is what? To know math, you need to what? Learn it, right? You need to learn how to do it, right? It doesn't matter what the numbers are, variables. What matters is the techniques, that you use to do it. Okay, so let's start out with number 1 on the review. Number 1 says x squared minus 2x plus 4, put a little meter here, guys, plus 4 is equal to 0, and the instruction is solve. Okay? So what do they mean by solve? What are we doing? If you saw this on the test, what would you do?
Factor.
Very good. Okay? We're actually solving for what? What are we solving for here? When it says solve for something, what are we solving for?
X.
X, right. We have to solve for x somehow here, don't we? Right? What is this called? What kind of equation is that? It's a quadratic equation, isn't it? In the form of ax squared plus bx plus c equals 0. You said factor, right? What's your name?
Kimberly.
Kimberly. So I don't see you over there. Kimberly said the factor. Is that good? Is that a good suggestion? Yes, it is, right? Now, how are the different ways you can factor something? You can use trial and error. You can use the AC method. You can use what? Everybody's favorite, completing the what? Square. Right? That's a joke, by the way. And you can also use the what? Quadratic equation. Quadratic formula. They all do the same thing, right? Okay? Now, the first thing you want to do is keep it simple. See if you can factor that, right? By trial and error. Can you? Well, we need an x times an x to get an what? X squared. This is strictly trial and error, guys. The coefficient in front of the leading term is 1, so we just have to ask that simple question. What two numbers multiply together give us 4, added together give us the middle coefficient, which is -2. Is that possible in this case?
No.
Here are the factors of 4. Right? Yes? Is that possible? And by the way, what's the play on the signs here before we even choose the numbers? You have a negative middle term, you have a positive end term. What do both of these have to be for that to play out?
Negative.
Very good. Okay. So, can you use any combination of those factors in order to get a -2 when you add them together?
2.
Well, -2 plus -2 is negative what?
Oh,
See what I'm saying? I'm going to put some numbers here, Kim, right? Okay? So if I put a 2 here and a 2 here, what am I going to get in the middle when I do my inside-outside product, when I FOIL?
-4.
Right. So that's no good, right? What else do we have? A 1 and a 4. That's even worse. That's going to give us a what? -4 plus -1 is a -5. Whoops. What happened? We can't do it with trial and error, right? Okay? But you want to check that because why? It's the quickest way to get there. So we are sort of stuck in the sense that we have to choose a method other than what? Trial and error basic. So, how do you want to do it?
Quadratic formula.
Yeah, I knew you were going to say that. Okay, so what is a quadratic formula?
Negative b
plus or minus the square root of b squared minus 4ac all over what? All over over,
2A.
right, 2A, good. Now, are we ready to identify what A, B, and C are?
1, oh wait,
Or not?
yeah.
Yes, we are, because it is in standard quadratic form already. Ax squared plus bx plus c equals 0. So what is A in our problem?
1.
1, positive 1. Sign goes with the coefficient, right? What is B?
-2.
Good. And what is C?
4.
4. Positive 4, right? Now, the rest is just what? Plug them in, solve for x, right? Remember, we're solving for x here, right? We're solutions for x. You know how this comes about, by the way? Where does this come from?
I don't know.
No, you don't know. This comes from completing the square on ax squared plus bx plus c equals 0. If you complete the square on that, you would solve for x, you get this in general form. Somebody was smart and said, I don't want to complete the square every time I have to do this. So they completed the square with the variables in place in general form and came up with this equation, right? Smart, right? Okay, so what are we plugging in here? That negative sign is part of the formula, right? So it's negative what?
2.
Negative what?
-1.
What are we plugging in here for B? What's B?
-2.
That negative sign is part of the formula, right? What am I plugging in here? -2, right? Okay, so be careful and make sure you include the negative sign, for the sign goes with the what? Coefficient, right? Plus or minus square root of -2, again, B.
And then negative.
We're plugging B's in, right?
Yes, it's -2.
-2 squared minus 4 times A times C. What's A in our problem?
1 and 4.
4, very good. Okay. All over what?
2 times 1.
Times 1. Good. Okay, it is what it is. Not always the case. Welcome, by the way.
Hello.
What's your name, huh?
Darian.
Darian? Okay. So the rest is just what? Cleaning this mess up, right? Okay? So what's a negative times a negative? A positive. So this is 2 plus or minus square root of what? What's -2 squared?
4.
4. That's a negative times a positive is a what? Negative 4 times 4 times 1 is what? 16, isn't it? Okay? All over what? 2. Now, you can already see the discriminant in here is going to end up being what? Negative, right? So what's that tell us? That's why we could not do that by trial and error. We're going to have what kind of answers? Imaginary, right? We're going to have I in the answer. Okay. So what's the next step? 2 plus or minus square root of -12 over 2. Good? Now, what do we have to do with that square root of -12, guys? Is that simplified? Can we simplify it?
It can't be negative.
Well, that's an imaginary number, right? You can't take the square root of a negative number. So how do we deal with that?
You take out the I.
Good, right? We're going to factor, I'm going to do a little step here. 2 plus or minus square root of -1 times square root of positive what? 12. See what I did? All over 2, right? Good. And this is going to be your I in the answer. Make sense? Now, 2 plus or minus I. But what's going on with the square root of 12 here? Does square root of 12 simplify or?
Yeah.
Yes. Good.
2 squared of 3.
Why? You want to look for factors of 12 that are perfect whats? Squares, right? Doesn't 12 have a factor that's a perfect square? 4, right? What are your perfect squares? Well, 1, right? But that's a trivial case. 2 squared is what?
4.
4. So you can take the square root of 4 and get 2, right? So what we want to do is we want to factor 12 into what? Square root of 3 times 4, right? We can break this 12 up under here. And what happens when we do that? What's going to happen to this part of that record? Square root of 4 is what? 2, isn't it? Good. So this becomes what? 2 plus or minus. Now I'm going to bring the 4, right? Square root of 4 is going to become 2 out front, right? So we got 2I radical what? 3 over 2. So far so good? Make sense? Okay. Are we done? Or can we simplify that a little further? We can simplify, right? Why? What do you notice? There's two ways of looking at this. You can factor a 2 out of the entire what? The numerator. Or you can say to yourself, how many individual terms are there up here? Terms are glued together by what? Multiplication, division. How many individual terms are there? 3, right? As long as you can factor something out of all of them, right? You don't have to factor out initially. So what number is in common with all 3 of those terms? 2. So we can factoring is division, right? So you can factor a 2 out of all 3 of those terms, and the answer is what? Let me bring it up here a little bit. What's going to go here? The number what? Factoring is division, so I'm dividing 2 by what? 2. What's 2 divided by 2? 1. Yeah. Plus or minus. What's this 2 becoming? 1 also, right? Times I square root of what? 3 over 1, right? But what's true about the number 1, guys? You do not need to what? Write it all the time, because if it's a coefficient in front of something, 1 times anything is the anything, and so forth. I can get rid of that, and I can get rid of that. How come I can't get rid of that one? What's the difference? Isn't this term separated from this term by a plus or minus sign? Right? Okay. So if I get rid of this, that whole thing's gone. Isn't that a different number? Yes, it is, right? So I have to keep the place with the 1 in this case. Okay, so your answer should be 1 plus or minus I radical 3, right? Which I believe is what? A, right? on your answer sheet, right? Good? Okay, good. So far so good?
Yes.
Okay. Now, number 2, any questions about that? You good, ladies? Okay, good about that. All right, number 2. I'll put the question up here, right? It says solve. Right? I know you have it in front of you, but this is being recorded also. So 8x to the 4th minus 18x cubed minus 5x squared is equal to 0. Okay? Solve for x. Holy moly, right? You guys probably haven't dealt with polynomials degree 4 too much, right?
Yeah.
So flag should go up. Boom, what's happening here? But what should you also always do when you solve or simplify anything? What's the first thing you should look for? Always, always, always.
LCD?
A GCF. Close enough. Right? I knew what you meant. GCF, right? You want to see if you can factor something out of all 3 terms, right? What do they have in common? Do they have anything in common? Well, we have the number 8, the number 18. They're negative, but I'm just looking at the absolute value. And the number 5. Do 18 and 5 have a GCF, a greatest common factor? No, because 5 is prime, right? Okay. And 8 and 8 do, right? They have a common factor, right? But that 5's there. So you have to be able to factor out of all 3. So the numbers, we can't do anything with the numbers. But what do you notice about the variables? Is there a variable in common? X. They're all x's, right? X, X, X. What's the rule when you're factoring out with something raised to a power? You can factor out the what? Highest or lowest?
Lowest.
Lowest, very good. You can take 2 out of 2, and you can take 2 out of 4, but you can't take 4 or 3 out of 2, can you? Very good. Okay, so your eye should go directly to the smallest exponent. We can factor that out. So if we factor that out, we have x squared. What's left? when you factor x squared out? Factoring is division, right?
Yeah.
So we're actually dividing this by x squared. Go ahead.
8x squared.
8x squared, very good. Minus,
18.
yeah, we're not touching the numbers, right? That's going to be x to the first, right? Minus
5.
5 only, right? Still equal to 0, by the way, right? We're solving. That should look a little more friendly to you guys, right? Okay? We'll address what this is out here later, okay? Good? So far, so good? Okay, what's another way of writing x squared? X times x, isn't it? Good. They're individual terms. That's now factored into its prime factorization, isn't it? Now, what's going on with that thing? What's it called? Trinomial. Trinomials factor into what? 2 binomials? Yes? I think we just kind of like tried to do that here, right? But
Yeah.
couldn't, right?
Yeah.
Couldn't because, I'm talking about trial and error, couldn't because the numbers weren't pretty, right? But you still want to try that here before you jump into the quadratic. This might be doable, right? Let's take a look at it. Equals 0, right? What's going on here? How do you do this by trial and error? You got to use AC method usually, or do you use trial and error, or both, or what's your choice? It's trial and error usually. Okay, so let's do trial and error. What's some obvious things going on here with this? Well, you need a plus sign and a minus sign to get a negative n term when you FOIL, right? So there's no guessing there. 5 only has factors of 1 and 5 on the end, right? No guessing there. We need an x, and we need an x to get an x squared first time around with the FOIL product. No guessing there. Where's the guessing come?
2, 4.
With the 8, right? Now, we have to put two numbers here that when multiplied together, when we FOIL, give us 8, but when everything is multiplied out, adds up to what? 18. What's a good way to start? Well, what are the factors of 8? 1 and 8 and 2 and what? 4. At a quick glance, you now want to look at the what? Middle coefficient. It's 18, right? Okay. What do you notice here? What's the other number we have to work with?
5.
5. Good. I'm kind of close to that problem. Any pairings here that kind of produce an 18?
4.
What's 4 times 5?
20.
What's 1 times 2? 2. What's 20 minus 2? 18. Oh, so there it is, right? Good. But we have to play around with the signs because we have to go back here and what? Look at this middle number. It's negative, isn't it? Okay. So we want it to end up being what? Negative. So how about if we put a what? We want the 4 to be with a what? 5 when we do our foiling. So we want the 20. And what's going to go here? The 2, right? Does that make sense? Okay. Now, what do we get if we actually FOIL this back out to check? We got 8x squared. That's good, right? And now when we do the outside inside, we get negative 20. Plus 2 is a negative 18. I got lucky. I hit it on the first time when I put it in, right? Negative 5 on the end. I think we're good to go, right?
Yeah.
Okay? Now, remember, all this prime factorization we just did is still set equal to 0, isn't it? So therefore, how do you solve for x? When you have a polynomial prime factor, you set each prime factor equal to what? 0. Good. Now, what's happening here with these two x's? You're just going to set each one equal to 0, right? It's called multiplicity. You only list the answer what? 1 time. Good. So I think we got that part of the answer already, right? X is equal to what? 0. What else? Yeah, we have to set each one of these prime binomials equal to 0 and solve for what? X. So what are we going to end up with? 4x plus 1 equals 0. Subtract 1 from both sides. 4x equals negative 1, right? Yes? And x is equal to what? Negative 1/4. Right? Careful with your signs. I have a lot of students that like do this in their head real quick, and for some reason they keep the sign of the original binomial. So make sure you realize you're solving for x. And what about this one here? 2x minus 5 equals 0. 2x equals positive 5 at pi to both sides. And x is equal to 5 halves. Good? Okay? So those are also solutions. Right? Negative 1/4 and 5 halves. Good? Now technically there's 4 solutions, which you would expect to happen because why? What's the degree of the polynomial? It's 4, right? That tells you how many solutions you are possibly going to end up. But when you have multiplicity, I'm getting out of the realm of things here, right? That just means something else is touching the axiom, okay? But don't worry about that. You just need to know that you don't have to write it twice. Good? So the answer should be, I didn't write it in order, but order doesn't matter when you write set notation, right? So it is what? D? On your sheet. By the way, I don't know if I mentioned this. The answers are on the left.
Last
Back sheet. Okay. Good. Make sense? Yes? No? Okay. All right. Can I go over to that board or at this point or not?
Yeah.
I don't want you to.
That's fine.
I'm just trying to leave that up there a little bit so they glance back at it.
Yeah.
You have
Absorb it.
more? Okay.
Oh, I'm sorry, hon. Yeah, that might help. Came in. You're welcome. Okay, so we did number 1 and 2, right? And I'll leave that up there. So number 3, let's do number 3. What's number 3? Number 3 says solve the square root of 2x plus 4 is equal to x. Okay. Is this stuff looking kind of familiar to you guys as I go through it, or some of it?
This one I kind of forgot.
Sorry?
I forgot.
You forgot it? Yeah, well, are you in a 16-week class, or
8,
you're in an 8? How about you?
16.
You're in 16, so you're especially you, right? Right. Stuff you did 15 weeks, 14 weeks ago. It's like, whoa. That's why it's important for people to do this. Right? It brings what you did in the past back to the front, because you're going to see it on the exam. Right? It's not that you don't know it. It's just been filed. Okay, so here we go. What's different about solving this? What jumps out at you guys? Radical sign in the equation, right? Okay, so let's remember that. We have to get x by itself. Well, this one's out of the radical, but that one's underneath the radical. So somehow we're going to have to get that x here out of the radical, right? So what happens here? I'm going to what? Subtract 4 from both sides, therefore isolating the radical, right? And the reason I'm going to do that is because why? What method are we going to do to get rid of that radical? What operation? What's the inverse operation of taking a nth root?
Square.
Yes, raising to the nth power, right? If this was a cube root, I could have gotten rid of it by cubing the entire left-hand side, right? This is a square root, right? So we're going to square the entire left-hand side. Yes? You with me? So I'm going to get rid of that radical sign. But if I square the entire left-hand side, I have to do what, guys? I have to also square the entire right-hand side of the equation. Right? Just like the addition property of equality, the multiplication property of equality. Sorry?
I thought it was going to be 1/2.
That's if you rewrite it. You're thinking of rewriting it, right? If I want to take square root of 2x and rewrite it with a, what, rational exponent, I could rewrite this as what? 2x to the 1/2 power. I'm just getting rid of the radical as it is, right? Okay. You can do that if you want. But then to get rid of 1/2, what are you going to have to do to the 1/2? Raise it to the second power, right? You see what I'm saying? Because the power raised to the power, 2 times 1/2 is 1. Right? Okay, so you're not wrong. It just
Okay.
it's like an extra step, right?
Yeah, we don't
Okay.
want that.
Yes. In math, you want to keep it simple, right? All right. So far, so good?
Yeah.
All right, so that's going to do something for us. It's going to get rid of this radical, and we're left with just 2x on the left. But what's the trade-off? What's on the right-hand side? X minus 4, the binomial squared. We have to actually FOIL that. Right? So what is the FOIL? You guys, can you do this, or do you want me to do it out by hand?
I do.
You can do it, okay. So what do we got? X squared. Outside is negative 4x, inside is negative 4x, that's negative 8x, right? When you add them together, and plus 16. Good? Okay, it's the same binomial, so you're multiplying it by itself. All right, now what? What's it starting to look like? What's it starting to look like? Quadratic. So solve for x, right? But what do we want on the left-hand side in this case? X squared is already on the right, isn't it? So what do you want on the left-hand side? Very good. You want 0 over here, don't you? Right? You want to set the quadratic, right, equal to 0. So I'm going to subtract 2x from both sides. Good? Which leaves us with 0 equals x squared, and this becomes minus 10x, right? Plus 16. Yeah, done. Okay. Now, what is the best thing to do here? What's the quickest way to get to the answer? Look at this trinomial. It's pretty friendly, right? Okay, so maybe we should just do a little trial and error factoring here. So 0 is equal to, let's assume we can do so at first, right? If not, we can revert the quadratic, right? You need an x and an x to get an x squared. What two numbers multiply together give you 18? Somehow added together give you the number 10?
8 and
2, 8, right? Good. Signs have to be both what?
2.
Negative, don't they? Because to get a negative middle term, you have to add 2 negatives when the end term is positive, because this is the multiplication part. So minus, minus, right? And now what?
X equals 2, x equals 8.
Okay, so we're going to say x minus 2 equals 0 as one possible solution, and x minus what? 8 equals 0 as another possible solution. This one's going to yield x equals what? 2. This one would yield x equals 8. Okay. Done? No. We're not done, guys. Why? What did we do during the process in this problem? And what do we have to do to make sure that these solutions are actually solutions? And what's the problem here? Yes. Whenever you square an even index radical, you must check your what? Solutions. Because extraneous solutions are produced, right? Algebraically. So we have to check both of these, right?
Yeah.
Okay, so let's go, right? I think I have, is that right? Yeah. Yeah, that's right. Okay. So now what?
Plug them in.
Plug them in, right? So let's start with a 2, right? Where are you going to put the 2? In the original what?
The x is
Yeah, I would go back to the original and put it in here, right? So if you put 2 in here, what do you get? Let's go over here. Am I going over too far? Or
You good?
are you good? Okay. If you plug for x equals 2 in the original, what do you get? Square root of 2 times what?
2.
2? Is that right? Plus what?
4.
4 equals what?
2.
2? Yeah? It's the square root of 4, which is equal to what?
2.
2. Plus 4? 2 plus 4 is what?
6. It's not.
6 is not equal to what? 2. So what happens here with this problem, guys? What do we have to do with the answer 2?
2
Yes, that's an extraneous solution. We have to get rid of it. We cannot keep it. Right? Make sense?
Yeah.
Even though we got it algebraically, it does not solve the original equation. Now, what happens if you plug an 8 back in there? Can you see what happens? This is the square root of 2 times 8, right?
Yeah.
Plus 4 is equal to 8. 2 times 8 is what? 16. The square root of 16 is what? 4. 4 plus 4 actually is 8. So 8 checks. So the answer to this number 3 is only what? 8. Does that make sense? Good? Okay. All right, very good. Now I'm going to have to get rid of some of this, guys, at this point. So we can move on. Now, I only did 3 problems, and it took me half an hour, right? Because I'm doing a lot of explaining. So what I can do is I can speed this up, right? And why don't I do that? And what I will do is do them, and you guys stop me if you have an issue. How's that? Right? Good. Because I'm sure he wants to eat dinner before 8 o'clock at night. Right? All right. All right, very good. So far we've dealt mostly with what? Mostly with what? Polynomials, that type of thing. Okay. So, number 4 is a little different. Number four is talking about a what? Inequality, right? So we have x squared plus 5x minus 6 is greater than 0. Now this is not really any different, is it, than what we just worked with before, except there's a what sign there? There's a greater than sign. It's an inequality, right? So it's going to have a set of numbers as a solution, not just individual numbers. Okay, well what is the technique you use to deal with this?
You're looking for positive numbers?
Say again.
You're looking for positive numbers, seeing that it's greater than
Good. Okay, but how do we determine which positive number?
a factor.
It doesn't this kind of look the same as what we were dealing with, except it has a what? Greater than sign. So can't we factor the left-hand side of the equation? Right? Trial and error on this one, guys, right?
Yeah.
What do you think? Positive middle, negative n term, you need a plus and a minus, right? How about a what? Positive 6 and a negative 1. So when you add them together, you get 6 minus 1 is a positive 5 and a negative 6 on the end. Does that look good?
Yeah.
Now here's the difference. When it's an inequality, what do you have to do? What are these representing now? Critical values. Right? Okay. I'm going to plot after I solve each one of these. This one's going to be x plus 6 equals 0. Let me actually bring this down a little bit. X is equal to negative what? 6. This one's going to yield what? X is equal to 1. On the left-hand side. Now I'm going to draw both of those critical values on the number line here. This is 1. And relatively speaking, negative 6 is to the left, true? What makes these critical values, by the way? Why are they called critical values? Well, what are the different combinations here, right? They actually touched on it, right? What has to be the case for this inequality to be true? Everything on the left has to be what? Positive, isn't it? Right? But what if one of these is negative? It's going to end up being false, isn't it? So what we do is, to see the play in the signs, we're going to actually test what's called the regions here that was created by the what? Critical values. How many regions do we have? 2 critical values create 3 regions, right? So So we're going to test region number 1, region number 2, and region number what? 3. Make sense? Good? Okay. It has to produce a true statement. So if I pull a number out of this region here, this is the number 1, it's not, I have to plug this back in. Now the easiest way to look at this one, guys, is if you plug it back in here, all you have to do is see how the signs play out, right? Okay. What number is between -6 and 1?
0.
Which is nice, right? 0, right? Because 0 is nice to work with, right? If you plug a 0 in here, what do you get? 0 plus 6 is 6. 0 minus 1 is -1. You get a positive times a negative, which is a what? Negative. Is a negative number greater than 0? No. So what's true about this middle region, region 2? It's all going to be what? False. Right? Isn't it? It does not produce a true state up here. Right? Okay, they're all going to produce what? Negative numbers. Make sense? Where's 0? Now, well, not 0. They'd be false. Negative in here, 0 at the critical values. Okay? So far, so good? Yeah, which we'll address later in the interval notation. Don't assume, right? I'm not going to say this. Don't assume that because the middle's false, the outsides are true, right? There are patterns here, right? There are reasons. Sometimes that's not always the case, especially in higher polynomials, but for now. So, what's a nice number to test out of 1? Well, keep it simple. Just go down to negative what? 7, right? If you put a negative 7 in here, what do you get? What's negative 7 plus 6? It's negative 1, right? And negative 7 minus 1 is negative 8. What's a negative times a negative? A positive, right? Is a positive number greater than 0? Yes. So this is what? True. And what's a nice number to use here? 2, right? So if you put a 2 in, 2 plus 6 is 8. 2 minus 1 is 1. And a positive times a positive is also a positive. So this is also what? True, isn't it? Good. So what are the actual solutions? Where are the points that produce a true statement here? Aren't they all down here? And aren't they all up here? Yes? Good. Those are the only set of points that we want for the answer. So, how do we write that? In interval notation. I'm noticing the answers are all in interval notation, aren't they? Good. So, going from left to right, right? You read and write interval notation, left to right. What's down at this end? Negative infinity. What's up at this end? Infinity. Infinities always have a what? Parentheses, right? Comma, up to the number -6. Question, bracket or parentheses and why? We need to look back. We need to look back at the original what? Yes, inequality sign. Does that inequality sign have an equal sign in it? No. So, what? -6 is not part of the what? Solution. That says strictly greater than. If this had an equal sign under here, yeah, then you would use a square bracket. See the difference? But since it says strictly greater than, we're going to also use a what? Parenthesis. Good. Now here's the problem. We do not want all this rigmarole here in area 2. Right? Shouldn't use the word area, it's not an area. Well, it's kind of area, I was looking at it. How are we going to get over that bridge on the number line? We want to stop here and start back up there, right?
Yeah.
So we're going to union, right? We're going to union this set of points with this set of points. We're going to jump over that bridge there and start back up at the number what? 1. Good. Now once again, is 1 included or not? No. Right? See this? Parenthesis up to infinity. Make sense? Yes? Okay. Kimberly? Good. Make sense though? Okay. All right, good. All right, very good. All right, so number 5, rolling right along here. So some of these take longer than others, right? Because they have drawings and they have, some of them we can do in like about a minute. Number 5, right, says solve. Right? So you're not going to be given much instruction on this file, right? Solve, factor solve. So you have to look at and know what you're dealing with, right? That's the important thing. And it says absolute value of x minus 2 is less than 3. And answer in interval notation again, as it says on your review sheet there, right? Okay. Now, do you guys remember these? Or not? You probably hit this stuff in the beginning of the course, right?
You just take it out of that.
Very good. Once the absolute value is isolated on one side, you rewrite this, right, as what? You remember what this becomes? When this comes out of the absolute value side, this becomes a what? 3-part inequality? When it's less than. When this is less than, right here, when that's less than, it becomes a 3-part inequality. What happens when it becomes greater, when you start with a greater than sign? Do you remember that?
No.
Right? If this was greater than, absolute value of x minus 2 is greater than 3, this goes to an OR statement, right? Okay? This would be what? Do you guys remember this or not?
Minus 3.
Good. Okay. I don't want to dwell on that. I'm going to focus more on this one, right? Because that's the one that was on the review sheet, right? Just for your information. Okay. Now, once again, we're solving for x, which means we have to isolate x, in this case x. How do you get x by itself here? What's being done to x? 2 is being subtracted, so what do we have to do? Add it, right? To get it to go to 0. So if we add 2, this will become what? X. But what does the addition or addition property of a quad, multiplication property say? You have to what? Whatever you do to one side of an equation, you have to do the other. But this time we don't have 2, we have what? 3. Right? We have to add 2 to all what? 3. Right? So 2 plus 2. What are we left with? X isolated. And what's over here? What's over here? 5. Now, what does this mean in interval notation, literally? Literally. Whatever I plug in here on the number line, right? Where's 5? Where's -1? The only points that are part of the solution are the points that are what? Between -1 and 5. Doesn't that what that means? Right? Any point I plug in here to make this true has to be greater than -1, but at the same time, what? Less than 5. Good? Okay, so there's our number line, but how do you take this graphic and change it into interval notation? Well, once again, interval notation's read and written left to right. So starting at what? -1. We're going to go up to what? 5. Now, once again, the question is, we're using parentheses or brackets in this case, and why or why not? Yeah, these are both what? Strictly less than, right? Signs, so we're going to use only what? Parentheses. Good? For the interval notation. So any point between -1 and 5 on the number line will satisfy this absolute value inequality. Good? Okay. Good. Okay. Let's take a look at number 6. Number 6 says, starting with x squared plus 2 over x minus 5 is less than or equal to, this time, right? 0. We're asked to do the same thing, right? Find the solutions. How do you do that? What's this called on the left-hand side here, by the way? This entire thing has a name, right? Rational expression, right? Which is a fraction that has variables in it. Good. The rational expression is going to produce our critical values in this case. And the reason is because what happened with that previous problem we did, what created the critical values here? You had, what, a play on the signs, right? You could have a what? A positive times a positive, a negative times a negative, a positive times a negative, and a negative times a positive. This went to what? Positive, positive, and these went to negative, right? Okay? Well, you can have the same thing with a quotient, can't you? Right? If I plug numbers in here, this can be a positive over a negative, or a positive over a positive, right? And that comes into play with the inequality sign. Does that make sense, guys? Okay, good. So the question is, how do we determine, right? Where's the cutoff points on the number line? Well, you do the same thing here as you would here, right? And by the way, this is sort of a simplified version of this problem. If you had something on the right-hand side, you can work with it on the right, but you really would want to get a 0 on the right-hand side. So it makes it quicker to what? Compare this sign to the number 0, right? Right? Like when D came in, she looked at something, she goes, yeah, they all got to be what? Positive over here, right? That's why the 0 is nice to work with. These all have to be what? Negative, right? Because negative numbers are less than 0, but it could be also what? Equal to 0, which we're going to address. So we're going to do the same thing. We're going to take the numerator and set it equal to what? 0. And we're going to take the what? Denominator and set it equal to 0. This gives us a critical value of 5. This numerator gives us a critical value of what? Negative 2/3. Good. Now I'm going to plot those two numbers on the number line in their respective places. We have negative 2/3 down here and positive 5 up here. So far, so good? All right, once again, how many regions?
3.
3, right? Where is 0? It's in the middle, isn't it? Okay, so use 0 as a test point. Real nice, right? When you plug a 0 in here, what do you get? 3 times 0 is 0. This becomes just 2, right? 2 over what? Negative 5, right? 2, positive 2 over negative 5. That's a negative what? 2/5, right? Isn't it? Is that less than 0? Or not?
Do you plug them in middle?
Yes. When you plug a test value in off the number line, right? You're plugging it in everywhere. Didn't we plug it in both on this one? Okay. We're just going vertically instead of horizontal, right? But you use the same method. Does that make sense? Okay. So what do we got here? Middle region is what? True or false?
True.
True, right? Okay, we ended up with a negative when we plug 0 in. So the middle region is true. What about this region? Well, what's a nice number to plug in down here? Well, this is negative 2/3. How about negative 1, right? Isn't that to the left, right? If you plug a negative 1 in here, you get negative 3 plus 2, which is a what? A negative, isn't it? And you plug a negative 1 in here, negative 1 minus 5 is a negative 6, which is a negative. What's a negative divided by a negative? A positive.
So it's false.
Very good. Okay. False, right? A positive number is not less than or equal to 0. Good. Now, obviously, when it's do something like 6 over here, right? So if you plug a 6 in, what do you get? Well, you can just eyeball this, right? You get a positive number up here, right? You get 20. And down here you get 1. So this is going to be also what? False, because you get a what? Positive number. No, Kim?
Yes, I got it.
You sure?
Yeah.
Okay. Tell me if I go too fast.
No, you're fine.
Okay. All right, so where are the solution points? In the what? Middle, right? Once again, we're going to use interval notation, right? So look at the sign we started with. It was a less than or what? Equal to sign. So what does the equal part say to do? Include the critical value, right? So what are we going to write here? Square brackets?
Yeah.
Yes? Right? Does that look good? The unfortunate part is not correct. And the reason is because why? These are a little tricky. You have to keep your eye peeled for what? Remember, the denominator got us one of those critical values, right? This here. What happens if we plug a 5 in the denominator? What's it become? 0. Therefore, it becomes undefined. So even though, right, this sign says less than or equal to, what do we have to make this sign? A parentheses. We have to get rid of the number 5 itself from the solution set because we are restricted from plugging 5 in the denominator. Make sense? Yep. I know. Kimberly?
Yeah.
Yes. You gonna remember that?
Yeah.
A lot of people forget, right? They get going too fast on a test and they see this, they do that, boo, 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 but they forget about the special condition of the problem they're working with, right? Okay. All right, very good. Okay, so here we go. This one. Little brain break here, guys. Number 7, right? For the function f of x equals 3x squared minus 2, find f of negative 3. What does that mean to do?
Okay.
Plug what in where?
X.
Say again?
The X.
X. Plug what in for the x?
Negative 3.
Good. This is f of x, right? But this is, we now know x is equal to negative 3. So you're going to take this number negative 3 and you're going to plug it back in here wherever you see the what? The number x, right? Okay, so really what we're doing is we're finding f of negative 3 is 3 times negative 3 squared minus 2. What's being squared here, guys? Just the negative what? 3. Good. So this becomes what? 3 times what? 9. Right? Minus 2, which is 27 minus 2, which is 25. Good. Okay. So you're hoping a lot of those on the test, right?
Yeah.
All right. All right, very good. Now, let's get into doing something like number 8. Number 8, right? This is more of a find the domain, right? A little less calculating here and a little more what? Thinking about what we're being asked to answer, right? So find the domain, right, of what? F of x is equal to square root of 3x minus 2. Now, first of all, let's define what's a domain of a function in English.
X.
The x's, right? And the x's that what? Define the function, vice versa, right? Okay, they represent their own function. What's the problem with this function? By the way, what kind of function is a square root function, right? Okay. What's the square root function look like? What's the base function? Looks like that, right? Okay. Why does it look like that? What's the smallest x you can plug in for f of x equals square root of x? What's the smallest x you can plug in and why? 0, right? In the real world. Right? Good? Well, we can plug a 0 in here or not? No, we can't, because why? 3 times 0 is 0, and 0 minus 2 is negative 2, or all of a sudden the imaginary one, right? So, but there is a number that will produce the minimum, right? The lower bound on the what? Domain. And how do we find that? Do you think? What's a good way to find that? What number are we allowed to have under here as a minimum? 0, right? Okay. So what if we set that under there, the discriminant equal to what? 0, right? Okay. So what is 3x minus 2 equal what? 0. What's that yield? 3x is equal to 2, x is equal to what? 2/3. Now what that means is if we plug a 2/3 in under here, we will end up with a what? A 0, right? Good. And that's okay, because the square root of 0 is what? 0, isn't it? But the question now is, what direction are we allowed to go here? Higher numbers or smaller numbers?
Higher.
Why? How'd you know that? Oh, good, right? Using visualization, excellent, right? But say you didn't have that graph in front of you. How would you test this? Well, you know these have to end up being what? Positive, right? So if 2/3, what's the next number up? Whole number. 1, right? Isn't it? So put a 1 in. 1 times 3 is 3. 3 minus 2 is what?
3 minus 2, 1.
Right? Yes? You with me, guys, or not? I got the next number up on the number line, right? If this is 2/3, if I'm going in the positive direction, if this is the direction the domain's going to be going, right? The next positive number up is what? That's an integer, 1, right? So I plugged 1 in and saw if it was okay, right? So if I plug a 1 in here, 1 times 3 is 3. 3 minus 2 is what? 1. It was positive though, right? So you can even check another one if you want. Put a what? 4 in. You're going to get a positive number. So you know that this number here, 2/3, is going to be the what? Lower. Right? The lower bound on the domain. Good? So what is the domain here? From 2/3 up to what?
Infinity.
Infinity. Very good. Okay. What kind of brackets or parentheses we using here? Well, infinity always gets what? Parentheses. 2/3 included or not? Can we use 2/3? Yes. Why? If you plug 2/3 in, you end up with what? 0. And 0 is a legitimate what? Discriminant. So we're going to have a what? Square bracket in 2/3. Good. Okay. Very good. All right, good. Okay. Number 9. Number 9 says determine the vertex of the quadratic function. And they really did a nice favor for us here, guys. They wrote the quadratic in a certain form here. Right? What form is this? Isn't that the vertex form? Right? You guys remember that? Y equals what? A times x minus h, the quantity squared, plus k, where what? The vertex is at what? H, K. Right? Did that ring a bell? Good. Okay. So now this is the form, the general form, right? Okay. It has a minus sign there, right? So what is actually our H in this problem? 3. Not negative 3, 3. Right? Okay, because the original what? Form had a negative sign here. If this would have been a plus 3, then H would have been what? Negative 3. Because then minus a negative 3 produced a positive 3. So what you do basically is you read, right? H is always the opposite side, but K always has the same side, right? So K in this problem is going to be 4. So what is the vertex in this particular problem?
3, 4.
3, 4. Right. Okay. Open it up or down. What's A? A is out here, but there is no number, so it must be what? 1? Positive 1, so it's opening what? Upward. Good. Okay. All right? All right. Good.
So what the axis of symmetry?
Say again?
What about the axis of symmetry?
What about it? What would it be? What would the axis of symmetry be? If this is the vertex, this is 3, 4, right? That's here, isn't it? So this is opening upward. Where's the axis of symmetry always? In a parabola, quadratic. Good. Isn't it? What's the equation of that line?
X equals 3.
X equals 3. X and 1 thing. Right? Good? Okay. Alright, very good. Okay. Why is it always the ones that know what they're doing come to the review? It actually works out great because I can. Alright, Dave. Alright. So let's look at number 10, right, which is similar to 9, except we're going to be dealing with a different shape. It's not a function this time. It's a circle, right? How come circles are not functions? Well, we'll get back. Let's think of the problem. This is the original, right? And I'll actually do this. I won't even draw it, right? This is the original problem. It's given in general form, x squared plus y squared minus 4x plus 6y minus 3 equals 0, right? Okay, I don't know if you guys remember that or not. Probably way back, right? This was what? A, B, C, D, E, right? Were the numbers, right? Okay. Now this was nice, but it doesn't tell us much of anything, does it? Right? So what we have is a little technique. We're going to put this in center radius form, right? Okay. You see how this was in what? Vertex form. This is actually taking something in the form of f of x equals ax squared plus bx plus c, right? And putting it into vertex form by completing the square, right? Well, guess what we're going to do? We're going to take the general form of the circle, and we're going to complete the square on the x's and the y variables, and put it into what's called center radius, right? Good? Okay, so here we go. First things first, group the x's together, leave a space, and group the what's? Y's. And now I'm also going to what? Add that 3. Add 3 to both sides. Get rid of that negative 3 on the left. Right? Okay? See what I did so far? Group the x terms, group the y, put the 3 on the right. Now we're going to complete the square on the x's and the y's. So what do we have to do here? How do you complete the square? We're going to create perfect square trinomials, right? That can be rewritten as one binomial squared. So what we have to do, we're creating this, right? So we're going to half b, right, the absolute value, because it's going to get squared. Half it, square it, and what? Add it, right? So what's half of 4? 2. 2 squared is 4. Add what? 4, right? Happens to be. That's a perfect square trinomial. Good? Half it squared, add it. What are we adding? 9, right? Good? But we changed the left-hand side of the equation. We added a 4 and a 9 there that weren't there. So what do we have to do to the right-hand side? Add a 4 and a what? 9, right? Don't forget it. Okay. This binomial becomes what? X minus the sign in the middle term is the sign in the binomial, right? Minus what? 2, right? It's either what? The square root of C, or half of B, right? The binomial square. The plus y plus 3, very good, squared equals what? 9 plus 4 is 13, plus 3 is what? 16, right? But what's another way of writing 16? 4 squared. Why is it important to write it that way? Because the center radius form, right, of a circle is x minus h squared plus y minus k squared equals r squared, where r is the radius, right? So don't forget to take the square root and rewrite it, right? If you have it in this form, the center is at, you guessed it, hk, right? And the radius is just that, it's r, right? Okay. Good? So what are we talking about here? What's the answer to this problem?
X to 2 and negative.
Now, careful with the signs, right? Look at the signs in the original form. They're both negative, right? Okay? That's a negative. So the center's going to be at 2 comma what? Yeah, this one has a plus 3, but the formula said it should be negative, right? So something made that negative sign in the formula become what? Positive. It must have been a negative what? 3. Good. And r is what? 4. Good. So you could graph that if you wanted to, right? Okay. Good. Okay, very good. I think that's what they were asking for, right?
Yeah.
Okay, so 2 negative 3, r equals 4, answers A. Okay? Now, number 11 says, right, find the length of the line segment from, right, negative 3, comma what? 2? To the point 5, negative 1, right? Okay. You guys want to see this, or you go with it? I mean, I don't want to bore you to death. But you're not boring? Okay. How do you find distance? What's the... Oh, I just gave it away. Right? Find the length. It says find the length, right? Find the length, right? Length is what? Distance. Isn't there a formula for distance? Right? What is it? D equals square root of what?
X.
Go ahead. Come on. Pull it up.
X and X.
X 2.
X 1.
Come on.
Oh, minus x
Good.
one,
Very good. Squared plus what?
y2
Yeah.
minus y1 squared.
I believe that's the distance formula, right? Okay, good. Now, what's the thing you need to remember to do here? You need to label these points. One point needs to be labeled x1, y1, and the other point needs to be labeled what?
x2 y2.
x2, y2, and you have to stick to that. Question, does it matter which one you call which? No. You can call this point x1, y1, and that one x2, y2. That's fine, right? You'll still get the same one. Okay, so it's plug-in time, guys. Right? Whoops. I knew that was going to happen sooner or later. So the distance is equal to what? Square root of, careful when you plug in, right? x2, what's x2? 5 minus, the negative sign is part of the formula. x1, what's x1?
Minus.
Negative 3. So it's 5 minus negative 3. Yes? Right. Plus y2 is negative 1, y1 is 2 squared, which gives us, what did I do? Left the negative sign off dead many, right? Typical type of what? Problem that you run into when you go too fast, right? So what's this in here now?
5 plus 3.
5 plus 3, which is what? 8, right? So it's 8 squared plus what? What's this become? Negative 1 minus 2 is negative what? 3. Negative 3 squared is what?
9.
But let me just write it like this. So far, so good? Okay. So now what do we have for D? Square root of what? 64 plus 9, which is the square root of what? 73? Yes? 73 simplifiable or not? No? Okay, good. What kind of number is 73? Maybe. Prime number? But anyway, it doesn't have any factors that are what? Perfect square. So it can't be simplified. Good. So the distance between these 2 points, right? Good. Which are not perfectly horizontal or vertical with respect to the xy axis is what? Square root of 50. Based on a Pythagorean theorem, by the way, right? Okay. Okay. So let's do number 12, right? What kind of symmetry in number 12? What kind of symmetry? Does the equation x squared minus 6x plus y squared equals 0 have, if any at all? Right? So what do you have to remember about this? How do you test for symmetry, guys? If you test for, let me do x-axis symmetry first. Doesn't matter which one. And then we're going to test for, what's the other axis? Y-axis symmetry. And what other kind of symmetry? What's a third kind?
Origin.
In college algebra is origin, right? Okay. For origin. I'll say with respect to, right, origin. Okay. So there are your 3. Now, very simply put, in order for you to have symmetry with respect to the origin, you have to have both of these. And if you have both of these, it's also what? Right? Okay. So let's start up here. What's the process of testing for x-axis symmetry? What do you do? What's the actual process, though? You put a what? Negative y in for what? Y. Yes? And to test for y-axis symmetry, you put a what, do you think?
Negative x.
A negative x in for x. Good. Okay, you say, okay, I can do that. Right? But what happens has to happen for it to have symmetry. After doing that, what? If there's symmetry, what happens back up here? You will end up back with the same what? Equation. Right? Okay, so in this case, am I going too far?
No, you're good.
Good. Okay. Let's put negative y in, right? What happens if you put a negative y in the original, and then we're going to put a negative x in the original? What happens? Well, if you put a negative y in for y, you get x squared minus 6x plus negative y squared equals 0. But what happens when you square negative y? Don't you end up back at what? Positive y squared? So what happened? By plugging negative y in, we ended up with the same equation. Therefore, what can you deduce? Is there x-axis symmetry?
Yeah.
Yes. Very good. You see how this works? Right? Now, what would be the next thing to test for, obviously? Y-axis, right? So we're going to do the same thing, but we're going to put a negative x in for x. Now here's how you can do this real quick. What's happening? If I put a negative x in where it's being squared, isn't that going to bring it back to positive? But what happens if I have an odd exponent? on x? What's going to happen to the sign here?
Makes it positive.
If I put a negative x in here, now it's going to be a negative times a negative is a what? Positive, and it changed, didn't it, right? So what does that mean about y-axis symmetry? No good, right? Yes, no?
No.
No, I don't think so. All right. You don't see how I evaluated it, or you don't understand this part?
No, I get it.
You got this,
Yeah.
right? If you put, let me go back and do it. If you put a negative x in here for every time you see an x, right? Remember, we're not touching y this time around, right? This is for y-axis, right? Test. If you evaluate this, what's negative x times negative x? It's positive x squared, isn't it? So that was the original, right? But what happens here now? A negative times a negative is a what? Right, but what was the original?
Okay.
Right, okay. So that's how come there is what? No y-axis. Now since there's no y, there can't be any what? With respect to the arc, right? So the answer to this question is, well, what? X-axis only. Good? Yes? Okay. All right, guys. So we're getting there. So we're about third through, right? Everyone good with that? The reason I'm being painstaking in the explanation with the explanation is because people are going to be looking. Right? I'm trying to be a little extra,
Yeah.
you know, explanatory. All right. So let's take a look at number 12 and 13. So 13, okay, now 13 starts getting a little, right, different. Number 13 says, find the vertex of the parabola, right? Okay. Now, it's giving a function, f of x is equal to negative 4x squared plus 40x minus 93. Right? Now that's the original quadratic. This would produce a parabola, right? The parabola has a vertex. Good. Now, what's the problem? Well, there's different ways you can do this. We could actually take all this mumbo jumbo over here and create a what? Vertex form by completing the square on the right hand side. Why do all that? Do you remember? Bless you. Do you remember what's true about h in the vertex? If you have this in, right, standard quadratic form, which is what? What's h equal to working with the coefficients? You remember that? Ring a bell? I'd go that route this time, right? Right. Because of the nature of the numbers and that thing. Most people don't fall back completing the square anyway. So what do we got here now? Plug it in. Negative b, but what's b in this problem? 40. All over 2. 2's part of the, right? This all comes, by the way, also from the quadratic type thing. And what? A. What's a in this problem? Negative 4, right? The sign goes with coefficient. Good? Okay. So what is h now? And a note here. Well, let's finish this, and then I'll talk about my note. This goes to negative 40 over what? Negative 8. But what's a negative times a negative? A positive, isn't it? So this just becomes plain old 40 over what? 8, which is what? 5. Now, before I do anything more, I'm going to go back and read the problem, right? And it says, it does say find the vertex, right? So it doesn't say just find H. It says find H and what? K. So we found this, right? But the vertex, written in the form of negative b over 2a, is actually what?
H.
Negative b over 2a is h, right? Okay. How would you get k? Well, k is y, isn't it? But isn't y f of x? Yeah. In any kind of function, y is just rewritten as the notation f of x, isn't it? Okay. But don't we already know x? Because isn't h x? So isn't this f of negative b over 2a? Very fancy, but what it means is to do what? Once you find x, which is h, you plug it back in where? The original equation, right? And solve for what? Y, which is k, right? Okay, now if you plug a 5 back in here and do your work, right, you're going to get negative what? 100, right? Because 5 squared is 25, right? Negative 100 plus 200 minus 93 is what? What's k? Actually, let me write this out. Negative 4, what am I plugging in? 5, right? Squared plus 40 times 5 minus 93. If you evaluate all this, you will end up with the number 7, I believe, right? Okay. So what is the vertex? 5, 7, isn't it? Yes? Make sense?
Yeah.
Okay. You sure, you sure, you sure? Okay. Alright, now number 14 is a little involved. Number 14 says, right, and you have your papers there. So what I'm going to do is just read it, right? You can read it off your papers. It says, find two numbers whose sum is 40. They just gave us a fact, didn't they? So how do I write two numbers whose sum is 40 if I don't know the numbers yet?
X and Y.
Very good. X plus y is equal to what? 40, right? Okay. But then it goes on and explains a little more, right? It says, such that the sum of the square of one number plus 6 times the other number is a minimum. Okay, now when we're talking about minimums here in college algebra, we're pretty much referring back to the what? Vertex of a parabola, right? There are two ways that if a parabola is a function, there are two ways it can open, right? It can open what? Up or down, right? Which is which? This would be a min, wouldn't it? And this would be a what? A max. Good? Okay. So let's see why they're giving us this other, this seems to be the direction we're going with this. Let's actually see why they gave this other description here. What's the other description? It said, find two numbers whose sum is 40, right? Such that the sum, right? The sum is addition, isn't it? Right? The sum of what? The square of one number, right? So what am I going to write? I got to take one of them and square it, right?
Yeah.
Well, let's square x. How's that? Right? Because usually we end up with x, right? Plus what? What does it say on there? Plus 6 times the other number. What's the other number? Since I squared x, the other number is what? Y. It says 6 times the other number, right? Is a min. Okay? Good? So what are we going to do with all of this? Right? Well, we're really talking about a function. Here's what we're talking about. A function of a parabola, quadratic, x squared, right? But we got a little problem. What's the problem? Well, yeah, we got two what? Variables here, right? No can do. But what do you notice? We have a second equation we can work with, right? Can't we take this equation here and rewrite it, right?
Y equals negative.
Very good. Y equals what? 40 minus x. I'm writing y in terms of x. Y. I'm going to take, I gotta use green. Green's getting lonely over here. I'm going to take this, and wherever I see a what? Y, I'm going to substitute this. So I'll have all x variables, right? Good? Okay, good. So this becomes what? X squared plus 6 times, now I hit a y, I'm going to write 40 minus x. But that becomes x squared. Now what I'm going to do is, right, because I see where this is going towards a quadratic, right? 6 times negative x is negative 6x, isn't it? Yes? I'm going backwards distribution, right? And this is what? Plus 2, what? 4 times 6 is 20, what? 4? 240. Is that good? Okay. Now, this is all a function, okay? What can we do with this? It says to find the minimum, right? Right? Okay? What are we working with here? What variable? X, right? So actually we're trying to find out what h is in the vertex. Does that make sense? So therefore what? What can we do with this? Well, this time I think we're forced to like complete the square on the right hand side, right? So this is going to be what? X squared minus 6x. I'm separating the x variables by themselves. I'm going to pull this 240 out further on the right because I'm going to complete the square on the x's. Half it, square it out. What am I adding, guys? 9, right? Good. And that's going to give us our perfect square trinomial to put it in vertex form. But I just changed the problem. Didn't I add 9 only to the right-hand side? Now I can't turn around and add it to the left-hand side, but I can what? Subtract. Very nice. Right? You can subtract it simultaneously from the right-hand side so it keeps the seesaw balance, right? Okay? And this all gives us the binomial what? X minus 3 squared, right? Perfect square trinomial. Then what happens here? Plus 2, 3, 1. Excuse me. This is actually in what? Vertex form now, isn't it? So what is h? What is h for our problem here? H is equal to what? 3. Right? Good. So I could start drawing this here if I wanted to. H is x, right? So 1, 2, 3. What's k in our problem? 231, right? Okay? That's way up here, isn't it? But we don't even care about that. We know what x is, don't we? Right? What is x equal to? Since h is equal to 3, isn't x equal to 3? Isn't h x? Can't I go back to this simple form of this equation? X plus the sum of two numbers has to add up to what? 40. Right here. What am I going to do with that 3? I'm going to plug it in here, right? So I'm going to take this and I'm going to what? Say 3 plus y equals 40. What does y have to equal? Right? Good. So what are the two numbers? 3 and what? 37. Right? Those are your two numbers. When added together will produce a minimum. Meaning a minimum what? A minimum solution. Okay. Sometimes you see these with products and things like that. It makes a little more sense maybe. Okay. Good. Okay, one of the trickier ones, by the way, right? Okay, so moving right along here, 15, right? 15 is, if f of x is equal to x squared minus x minus 1, and we have a second function, g of x is equal to negative x plus 3, it says find you guys know what is fog, right? Right. What this is actually is, it's a composition operator. The circle is a composition operator, right? And what you're doing is you're actually mapping this function onto that function, right? Okay, now, that's all nice, but most people remember fog, right? Find the composition of f, right, and g with respect to x, okay? But what's the thing you want to remember when you're working with these? Order matters, right? The first function is the outside function. So the best way to deal with these is to rewrite this as f of g of x. Good? And work with it like that, because then it becomes very simple and very obvious. What are we doing here, actually? If I said, what's f of 1, what would you do? You'd go to f of x, and wherever you saw an x, you'd put the number what? 1, wouldn't you? So this would be 1 squared minus 1 minus 1, right? But what we're going to do here is, instead of putting a number in, wherever you see an x and f of x, you're going to put the entire what? G of x function in here, right? So what I'm going to do is I'm going to rewrite f of x. And every time I see an x, I'm going to leave a what? Little room to actually write negative x plus 3. Okay? So this goes to what? F of g of x, right, is actually f of what? What are we plugging in? Negative x plus 3, aren't we? And this goes to what? Well, where's f of x? Here's f of x, right? So this is going to go to what? I see an x squared, so I'm going to leave space so I can put the entire what? G of x function in here. Make sense? Minus, parentheses, negative x plus 3, right? That's just plain old x by itself, right? Minus 1. Now 1's a constant on the end, right? Now if I did all my plugging incorrectly, now we can expand this out. What happens here? We have to what? Square this binomial, don't we? So what's this become? Negative x plus 3 times itself. A little weird looking, different looking, because the negative sign's in front of the what? X. But that's okay. Negative x times negative x is positive x squared, isn't it? Right? Outside, negative 3x. Inside, negative 3x. Add them together, you get negative 6x, right? And on the end, plus what? 9. Distribution of the sign, right? Negative times a negative is a what? Positive, right? So plus x, and then minus what? 3 minus 1, right? So if I have my signs all correct, we end up with the what? X squared, negative 6, plus 1 is a negative what? 5x. And 9 minus 3 minus 1 is plus 5. Okay? Good. So x squared minus 5x plus 5. So it should be b, right? And it is. Okay.